There we go. All right. Let me just drop for a few seconds here. I am putting some little foam feet on the bottom of the radio. Well, that's better. I can hear the radio better now. Good evening, everybody. This is Neil, W2NDG, on the Overlook Mountain Amateur Radio Club's Sunday Night Science and Technology Net. Let's pause real quick for any emergency or priority traffic. Anybody have any emergencies out there? Nothing heard. Well, if you have an emergency while we are operating the net, please just interrupt us with your call sign and let us know that you have an emergency, and we'll switch right over to you. All right. So, once again, you have tuned to the Overlook Mountain Sunday Night Science and Technology Net at 8 p.m. on the repeater of the Overlook Mountain Amateur Radio Club on 146.805 megahertz with a negative 600 kilohertz shift and a PL tone of 103.5 hertz. We are also on YouTube if you want to watch on there. And the best way to find us is either searching out the Overlook Mountain Amateur Radio Club's Facebook page, and we're linked there, or you can just search Google for W2NDG. That's Whiskey 2, November, Delta, Golf, Science, and Technology. And watch along. And please, if you're watching, let me know you're around. Throw a comment out if you'd like, and we'll try to get you involved in the discussion. What's tonight's discussion? Well, something came up this week. And I know we've talked about water, kind of. But as I was talking to Jim about that, it would be interesting after the crazy flood we had this past week to talk about water again. I was thinking, maybe not water, but what water can do, the damage that it causes, the incredible power that it has. And Jim kind of said, well, we can sway that in the direction of, how does the foundation on your house work? Different types of foundations, what can go wrong? Basically, the physics of your home and building. And how can you, keep bad things from happening, and what are the bad things that can happen? This can go in a number of different directions, but I kind of like the subject, and we can definitely expand on this a little bit. So, but let's see if Jim is out there tonight. My sidekick on this net, Jim, K2BHM, are you with us?
I am here. Good evening, everybody. Jim, K2BHM.
All right. And I think with this subject, you may end up doing some of the heavy lifting here because you have more engineering experience than I do, and might be interesting. So, and I think our participants are going to guide us on this one. Talk about issues you've had and resolutions you've come up with, or ask questions. If you've seen something go wrong, or somebody who's had this problem or that problem, and let's talk about it. But let me explain first what happened here, and then I'll hand it over to Jim. We had a crazy storm this past week that really centered right on this part of the valley, from probably just south of New Paltz up to around Rosendale. If you look at the rainfall map from that storm, we really got hit hard here. And even though we had more rain when those hurricanes came through in the fall, this was a much shorter event. We saw more water here. I had shared a couple of pictures to the club, and the Wallkill Flats down here where the cornfields are had more water than they did when we had the hurricanes come through. And that just really speaks for how much rain came down in how short a period of time. So what happened? I don't have a huge problem here. I don't have, I didn't have a structural problem. I didn't have, furniture floating in my basement. But for everything that's been done to this house over the years before I bought it, sump pump, second foundation with water collection gap between the two foundations, reworking all the gutters, and everything else they did, I still get some water in the basement, and I see previous signs of structural issues that came about a long time ago when they had more serious water problems back before they did the work that they did. So, I've been talking to a lot of people about, what can I do? What can actually be done? There's different ways of taking care of things. And I have a number of different directions I can go in. I don't want to empty out my entire basement and jackhammer up the perimeter and, do a B-dry system, but that might be the way to go. And then, what is a B-dry system? Some of you may not know what that is. There's a lot of things to discuss here, but the previous signs of damage here were a bowed wall in my foundation. And when the house was first purchased by me, the inspector pointed it out, and he said, if you look at this, this happened a very long time ago, and it's not in any danger of collapsing. But, he pointed it out to me and showed, whatever did this was fixed, because this basement doesn't look like it's constantly been underwater. The weather events that have caused water to come in, other than little, tiny dark spots here and there of seepage, have been unprecedented weather events. Some think that we're heading into a period of time of climate change. Whether that's related to this or that, the other thing, is a discussion for another night. But we are definitely seeing changes in weather patterns. No one can argue that. We're seeing more severe storms more often, and more unexplainable things that don't really happen all that often happen. So I think we have to start thinking about stuff like that. And that's, maybe a subject for another night again. We had a great weather talk one night. We can get into severe weather another night. So anyway, this is kind of a free form subject, and we can go in a number of different directions. So I'm going to hand it over to Jim next. But first, I want to say hi to K2UA, Russ, who checked in on YouTube. Russ and I go way back. Russ tried to get me to become a ham a long time ago, and I'm sure he's glad that I finally pulled the trigger and did it, because I should have done it a long time ago. So good evening, Russ. Good to see you here. Now it goes over to Jim, K2BHM, for anything on the topic, and then we'll do some check-ins.
K2BHM, Jim here. Well, I was thinking, with everybody having water problems and pumping out the cellars and stuff like that, and other people saying, gee, I'm fine. They didn't have any water. It might be interesting to explore what goes beyond the line of sight. You can out in your cellar, you see 4 walls and a floor, but there's a lot more going on that you don't see. And there's different ways of doing it. And I thought it might be fun to go in there and explore that and see what some of the different methods are, and get a better understanding of what is done to mitigate water, and what happens when it fails, what happens when it gets overloaded. Kind of get a better understanding of what's going on with it, and maybe a little insight into why it's happening and what you might do to make it less of a problem. So I don't know if you want to start right off with that, or did you want to take check-ins first to see who's around? Back to you, Neil, K2BHM.
I think we'll take the rounds and run some check-ins first here. But yeah, definitely an interesting topic. And, having been through the 2 awful hurricanes in recent history on Long Island, including Superstorm Sandy. Even though I wasn't in an area that flooded, I do have a lot of firsthand or secondhand knowledge, I guess, from people who were. And there's a lot of interesting things that happen when this stuff occurs. You build a house in an area that is prone to it, and you really have to make sure you're prepared for it, I guess. So, all right, let's see who's out there tonight and check in. You can give me your call sign, your name, and your location. And as I said, if you're watching on YouTube, you can also participate in the discussion if you want. Just throw some comments in the chat. All right. So people on the repeater, please come now.
Now. Guess I got it. Enter UIQ, Paul. Head control. Here is KB2, GGF, Matt, and Kerhonkson. Head control. This is a KD2 TVS loop.
All right, that's a good start. So I've got Jim and Paul, A3UIQ, Matt, KB2GGF, Lou, KD2 TVS. And we've got some people online as well. My brother Lee checked in, and CJ, it looks like, is on there. Excellent. So, and CJ used to have a net at this time slot, and as he gets back into working the earth, maybe we'll have him on either as a regular guest or guest host. So I would like that. All right. So let's go around real quick and we'll do a quick round just to get some thoughts as to what direction people want to go in. So, Paul, N3UIQ, you're up first.
I've seen so many pictures of so many floods and so many things that happen during floods. I don't know where to begin. But steam power. Now, I tell you what, your buddy there knows about steam power. N3UIQ.
Which buddy would that be?
Your co-host. I think he's built a steam engine.
Yes, little dollhouse sized ones, but I'm sure he's done larger ones too. Yeah, no, that was neat stuff when Jim was taking us through that. I think I was still in Poughkeepsie, basically living in my dining room during the pandemic. All right, no, interesting topic. Matt, KB2GGF. Any thoughts on this topic or directions you'd like to see it go in?
Good evening, Neil. Hello, Jim. Hello, Ned. Do have some flooding issues here and a couple of practical things that I could use advice and insight on. One being I have an area that floods in the basement, and it doesn't get much deeper than 3/4 of an inch, but it covers a large area. And basically, it's overflow from the perimeter drains. We did have the perimeter jackhammered and plastic drain pipe put in on a gravel bed, and then a skim of concrete over that. There's a gap at the wall about an inch wide all around the perimeter, so the water should go in there and drain and go to the sump pump. And most of it does, but it doesn't seem to have enough capacity, and it backs up there. So that I got to contend with. And outside, about 8 feet away from the foundation on the south side and lower in elevation, there's a really swampy area that we put in the so-called French drain about 30 years ago, and that seems to be ineffective, and I suspect it's filled up with silt. So run-of-the-mill stuff, but that's what I got. Back to net, KB2, GGF.
Yeah, I have similar issues here with just, something that was put in a long time ago that's probably not working the way it's supposed to anymore. But yeah, the failed French drain. I remember when I was a kid, my father and my brother explaining to me, our neighbor had a dry well, and I remember, being like in the woods behind their house and seeing this pipe, draining into like a bunch of gravel when their washing machine would be running, and asking about it and them explaining it to me. And I was like, well, why don't we have one of those? And the answer is because, well, they only last, I forget what the number was, a certain number of years. And then you have to, redo them, put them somewhere else or dig them up again and redo them. And that makes sense. Little quick funny story for you, Matt. The house that Jill and I rented before we moved here from Long Island was our landlord was fantastic, great guy, bit of an engineer himself. Jim would have gotten along with him really well. And he became known on the cul-de-sac there as the dry well king. He was putting in dry wells for all the people there. And he had in that house, there were 3 or 4 separate ones because the house had 2 laundry rooms. It was, until we moved in, a 2-family house. And he switched it, converted it back. But he had a dry well for the laundry room downstairs, a dry well for the laundry room. There was a second laundry room, I guess. I'm trying to remember where it was in that house. I guess in the garage. And then another one just for the gray water from the dishwasher. And I think he had one that a bunch of the downspouts fed into. As some of the neighbors came to him and asked him to do them, one of the neighbors had one and said, "It's not working. It's backing up. Can you check and see what's going on?" And what had happened, the repeater wants me to say, W2NDG on the OMARC Sunday Night Science and Technology Net. They had run the kitchen sink into the dry well, including the disposal. And that didn't work well. Just back to Matt for a comment on that. And then we'll go to
Yeah, that's pretty much how I figured. That's just a case of the drain isn't draining anymore, so you need to redo it with the French drains or like that, or even the perimeter drains. I'm beginning to suspect that they may be clogged. That would probably be a good place to deploy the optical camera, the fiber optic camera, so you can snake it and see what's what with what. Back to that, KB2 GGF.
Yes, for sure. And actually, Jack had one of those. We were using it for something else when we were trying to do some plumbing. It was quite interesting. But yeah, here, I hope there's no members of the town of Lloyd government or local building inspectors participating in the net tonight. But my washing machine drains into my sump pump hole, and that makes things interesting. Someone told me that over the years they've been with regulations and building permits on again and off again with dry wells, and currently it's off. I'm not supposed to have one, and well, I don't technically. Depends on how you look at it, I guess. So, all right, Lou, KD2 TBS from West Milford. How you doing tonight?
I'm doing good, I'm doing good. KD2 TBS. And good evening to you, and good evening to everyone else on the net that's participating tonight. The theory of hydraulics and water. Yeah, interesting. I myself at this house, I've only had some seepage 1 year. It was a year where there was a lot of snow that fell, and right in the spring, we still had a lot of snow left, and we got some heavy rains, and it must have rained like for 3 days with all this stuff just kept melting, and then between that and the water, I think we had like just a little wet spot over one side of the house, right where I'm sitting at right now. And it basically, I just kept towels there, stopped it all up. Never happened again. Never happened again. But I remember I've been in people's houses that have issues. My sister, when she had her house down in a town called Bergenfield, New Jersey, they had some weird things going on in that neighborhood, or her street. And I remember something about her telling me there was some kind of underground stream or something that ran between her house and her backyard. And she had a small backyard. I think it probably went out maybe 30 feet, something like that, 20 feet. And then there was the neighbor's backyard. And it seemed like her property was higher than the property behind her. And I was always one time I asked her, I says, why is your neighbor's backyard so muddy and wet and stuff like that? She goes to me, well, there's all the water that runs off of these properties here, and they just run it back into his backyard. And I mean, it was like a muddy mess. I said, wow, I'd hate to be the guy that owned that house and try to sell it without having some kind of remediation done to it to keep from having a backyard that was more like, I guess I wasn't in Vietnam, but I would imagine the swampy jungles of Vietnam. And that was a mess. I remember when she had her sump pump. I remember one time I had to go over and replace it for her. Yeah, they would pump out. They all had PVC pipes that led out to the front curb in the front of the house, and you could tell when when it was raining, all the streams were coming up, and there's some holes were getting filled. You could just drive down that street and just see water being shot out in the middle of the street. I guess it went down the drains, but that must have been a mess coming out one place and going down some other place, and a real mess. And let me reset. Yeah, this week there was during all those rainstorms, there was a mess down in a town called New Milford. And that's down by her, not too far from where she used to live. And they have a lot of low areas in their town, and right by the Hackensack River. And anytime I guess it rains, I think they were talking about something like 3-4 inches of rain came down within an hour or something like, with a heavy downpour. And the low-lying areas of that town just rose just to the level of the river. And seems like most of the people were probably up to their doors and in water, and I can imagine the messes their basements were. But yeah, I mean, hydraulics really does mess on some houses, and stuff like that. The only other story I remember, is when I was living out in Missouri and St. Louis. I was working for the airlines at the time, and got furloughed out of the New York area. Ended up going out there. I actually went out there about 3 times. We always lived near an area out west of the airport that was called the Merrimack River, and we're right near it. But I remember there was a lot of trailer parks and right adjacent to that river, and every time it rained heavy, all those trailer parks and everything would all just get flooded. And I was just always wondering, the trailers, why don't they just move them out of there? Or, why would you want to live there? But, man, I guess people are set in their ways. They must like their neighborhoods or something. Or maybe they're just poor enough not to be able to move. So it's crazy. But anyways, I'll send it back to you, Neil, KD2TVS.
All right, Lou, thanks. And all right, so I mean, nobody is a stranger to this, whether it's your home, if you don't have issues in your own home, somebody who's had issues. I remember one last comment I'll make: when you're dealing with the type of flooding that comes from a coastline or a river that's escaped its banks, whatever it is, you hear this phrase uttered when people are trying to keep their house from flooding. And that phrase is, water always seeks its own level. There's only so much you can do. And I'll throw it over to Jim, who may expand on that, but I'm sure he has other stuff to talk about. So K2BHM, take it away.
Thanks, Neil. Jim, K2BHM here. Well, to start with, there's a lot of dependency on what type of soil you have around the house. So much so that before you even build the house, they'll go and dig a little hole and dump a certain amount of water in it and come back a certain specified time later and see how much water's left. They call that a perk test. And from that, they'll decide, the engineers will decide what type of basement system you need. So anyhow, basically you start with a footing, and then you've got a house, and what goes in between the two is called the foundation, and there are lots of different options there. So let's start with the footing. Basically, you dig a hole, and the bottom of the footing should be at least 4 foot underground here for frost requirements. You put a couple of planks down and stake them and so forth, and pour your footing. Footing is typically 16 inches wide and 8 inches high for the standard house. And at that point, you can either take the forms off, or you take the inside forms off and raise the outside forms 3-4 inches and pour the cellar floor over the top of everything. That would be a monolithic system. Let me drop. Okay, so now outside the footing, they would put in some crushed stone, and they would put in a perforated pipe around there for drainage. And the two opposite corners typically would go out to a dry well or some other methodology of getting rid of the water. And years ago, that's all they did, was they just put the pipe there, and then they would take some roofing cement or tar or something like that and coat the outside of the foundation wall with that to prevent the water from penetrating, and you were good to go. And they found out that after 20, 30 years, the sand or silt or whatever migrated and plugged up those pipes. So they started putting a fabric over the top of the pipe to exclude the fine particles from getting in and clogging the pipe. Let me drop again. So then they also found out that over the years, there are small cracks in the foundation that will eventually let the water through. So they came up with this solution of putting this plastic on the outside of the foundation up against the wall. They had little dimples on it, made a little space, so whatever water did make it through had a good low resistance path, just like a ground wire. Had a good path down to the drain pipe, and hopefully get rid of it fast that way. So different terminology, different technology. They would put like a porous fabric on it, or a plastic piece with the bumps, several different things over the years to provide a path of least resistance for the water. Anyhow, so now you've got a foundation. You put a wall up on the footing. The foundation wall can be either concrete blocks or poured concrete wall. Either way, over the years, you get hairline cracks through the concrete block joints, or you have holes through the foundation for the tie rods that hold the poured concrete forms together. You try and seal them and all that, but after about 20, 30 years, they can develop a leak, and then you've got water inside. Let me drop again. So, okay, we talked about a floor. The floor can be straight out right across the top of the footings, or they could just put the foundation up on top of the footings and the floor pours up to the inside of the wall. And that leaves a crack there. So any water that wants to come up on the inside of the footing has a place to go and come up and get right through and onto your floor. So the other technology is to leave a gap about an inch wide or so. And sometimes what they'll do is they'll take 1 inch thick styrofoam insulation material and put a 3 inch wide strip on top of the footing up against the wall and pour the concrete to that. And then leave a hole over in the corner to put a little well in for a sump pump. And then they come along and pull that foam insulation material out and make a perimeter drain that goes all the way around the inside and lets the water that does come through give it a place to go to the sump pump. And depending on what your conditions are, they'll go one way, try and keep it all out, or go the other way and try and give it a place to go when it does come in. So anyhow, that's pretty much the technology there. They do have other solutions, like a dry lock basement sealer. It's a masonry paint that supposedly seals the cracks, keeps the water from coming in. Drop again. And then the other solution is like we're talking about a B-dry system or Adirondack basement systems or whatever. In the case of where the floor goes right through over the top of the footing, there is no drain between the floor and the wall. So what they do is they have this piece of plastic. It looks like a piece of baseboard molding. It's got a flange on the bottom and a flange on the top where you can adhere it to the floor and to the wall. And it goes all the way around the perimeter. And they'll drill little holes into the concrete block holes so that it gives a chance for the water to drain out into this molding-like thing and channel the water over to the sump hole that they put in over the corner. And they can retrofit a drain around the inside of the perimeter without getting down there and chopping away the concrete. So anyhow, those are pretty much the ideas at this point. Why don't we pass it around and see if we got any comments or questions or whatever, and where to take it from here. Back to you, Neil, K2BHM.
Great, Jim. Thanks a lot. It's basically what I've been envisioning, and I've seen this in houses, and I've also seen the retrofit side of that, when they didn't build it that way and they added it later. I know, what was done here, probably worked when they did it. And it's just that the age of the house, the settling, has produced gaps and cracks, and that's where I'm seeing it come in. I might be able to get most of it to stop just by, I assume they clean the walls with like an acid first, and then having somebody go through and just reseal that joint between the floor and the wall, and then a couple of feet up the wall. I took pictures this time of every place that I could see where it was coming in, and it's mostly right at that, that joint between the wall and the floor. Here, it's a little unique what they did, because they had so much water, I guess, in the original house. They poured a second foundation, and as far as I can see from looking in the sump pump hole, they put a load of like stone between the two foundations. I assume there's probably some sort of channelized, medium as well to make the water flow from between the two foundation layers. I really don't know what's in there because I can't see it, but the engineering makes sense if they sloped it correctly, and the water does mostly collect in that hole. It's just the areas where it breaches into the, on top of the newer foundation now. So once again, I can probably fix it just by doing some resealing, but I think I have to worry a little bit about what's going on outside the house as well when I look at the yard and how the water pools and things like that. It's probably time to look into some sort of drainage. Although it's hard because things aren't all that sloped here and we're pretty low already. But I think there's enough of a slope to the woods that I can probably get away with it. So, does anybody else want to check in real quick before we run back up to the top? This is W2NDG and K2BHM on the Overlook Mountain Sunday night Science and Technology Net. Please come down. All right. So let's go back up to Paul in 3EYQ. I know that night when I first announced that I was starting to see a little bit come in, and I think you commented, I don't even want to look at my basement. Your thoughts on Jim's engineering primer on how this all works?
We have water in our basement too, but it's all right. Well, as you can tell, I got in the background, so not much going on here. I don't know. We just deal with it right now. It's an older house, built in the 1850s, so what do you want? Enter UIQ.
You're right. I know that noise. I think one of my cats understands that noise. Next over to Matt, KB2GGF. Jim's explanation help you a little?
Yep. It's all pretty familiar stuff that you pick up over time if you want to stay out of the water. But what Paul just said about old house, my previous residence to this was in an old farmhouse that was built in the 1770s in central New York, and it had a dug basement that later my landlord, actually, when he was a kid, he and his brothers built, they poured a concrete foundation, one wheelbarrow at a time. And they actually engineered it pretty well. The floor was sloped toward the center from all four walls, and there was a channel that ran, it was like a 6x6 channel that ran through the center and to the low outside wall, low point on the low outside wall. And they had a grate there, a cast iron grate, and some quarter-inch screening over it. So it was all accessible, easy to clean out like that, and gravity drained that 6x6 cavity fine. I never saw it overflow in the worst weather. So, and it would only flow 4 or 5 times a year, but if you didn't have good drains there, the basement would have filled up. So it was very simple. It was good enough for the Romans with their aqueducts. I think gravity drainage is something to really shoot for, but to retrofit a place, yeah, okay, you got trouble there. It's complex. What I got to work out is some sort of alarm that will go off with a half-inch of water on a flat plane. KB2 GGF, back to net.
Well, thanks, Matt. Yeah. We started talking about the old house. It reminded me, a good friend of mine that I grew up with. He's not with us anymore, unfortunately, but the house that his parents bought when he first moved here was in Woodstock, right on Cena Road. And it was one of those old houses with dirt floor basement, but a lot of the basement had been carved out of the rock formations near the Sawkill Creek. And he had a fresh water spring in his basement, which makes things even more interesting. Um, so there you have a case where water in the basement that was actually probably supposed to be there. I'm sure some of that was done on purpose back when they first did it. It's probably where the house got its water from. So, but yeah, they had it kind of part of the basement that was rock. The water would come out a couple of small holes in the rock, and then they had carved like a little waterfall channel thing down into a hole where they had a sump pump. It was really cool. His dad, they didn't live here long enough that he did it, but he always said he wanted to make like a little water feature in the basement, put some lights on it and everything. Never actually happened. So, all right. So, on to Lou, KD2TVS. You're up next.
Thank you, Neil. KD2TVS here. Interesting. Yeah, and I was just remembering my buddy's house up in Vermont. They originally lived down by Atlantic City, but I guess he got tired of living down there. That's where he grew up, in the Philadelphia area, Atlantic City, and decided to move up to Vermont. Moved up near a lake called Lake Almocene. We usually go up there fishing every summer. We have this, we usually pick a week. We just get together for 2 or 3 days, go up there fishing on this pontoon boat and have a good time. Co-workers and good friends. But anyways, his house, when he bought that house up there, the back of his house comes right up against the side of a hill and a mountain. I guess they're known for slate rock up there. And when you come out his back door, the rock is right there. I mean, it's just like it goes off probably at a 45-degree angle up to the top of the hill. And he always has fun, I guess, with heavy rains and stuff, because either he didn't really think about it or he really wanted to buy that house that bad because it was across the street from a lake, and that's what he wanted, because he wanted to be able to go fishing anytime he wanted to go to. Take out his boat. Let me just reset. And that water would come right up against his foundation downstairs, and his back room down there would always smell musty and be moist and stuff like that. It's like a project he's going to eventually have to take up and either, break away some of that stone, and luckily if it's shell, and they could just chip at it or whatever he can do at it, and put a French drain in there just to get the water to go around it. But it's interesting, like how sometimes, and this house was something. I'll tell you a story about this house. In Vermont, for some reason, he seems to think, and I guess he must have got the info from a lot of the people that live up in that area, that people tend to do strange things to their houses, and as far as additions, and either their townships don't look into any of this stuff, or since they don't file for permits, there's no engineers or anything, anybody with any common sense sometimes looking at what they do. Hold on a second. So I remember his house was original, and then they put in an addition to it for a kitchen. So it kind of comes off as an L to the house, to the front of the house, to the deck. And the guy just put it up there with, 2x4s. And I remember when we were putting this door in, this big, nice door that he bought from Home Depot. We had to put it in. We couldn't even get it past the eave. We actually had to, when we took out the old door and framed the new one, we actually have to go under the eave and use an automobile floor jack on his deck just to raise it so we could get it in. How you have to sometimes work around what some of these people do. But not water related. Hold on a second. We had to take a wall out of his old kitchen so he can make it wider. And it was like a corner of the house where they kept a futon, and there was a small kitchen there. So he had wires, and he had wires running through his walls. And you would think that, you would route these wires properly, but this guy just, wherever he put an outlet, he just used the little twist tie to join the wires. You know, the little caps, colored caps. I forget what they call them. Just to join all his wires. And when we knocked down the wall, we found all these things. They were just everywhere he wanted to branch off some power, he would just do that. And put those twisties on and wrap it up in electrical wire and electrical tape, and that was it. So when we took the wall down, I said, okay, we need to kill this breaker if we're going to, we cut this wire, and so we don't get it out of the way. And it was dead, according to what we thought at the farthest point, that there was no power there because we plugged in the lamp. But when my buddy decided to cut the wire, both the light shot out of there. So I think to this day, he still doesn't know where that power from that branch comes in at. But let me just reset a second. I think a lot of the problem with a lot of these older houses, and I guess like Paul says, the 1850s and stuff like that, these houses were built in an era where, at the time, they didn't have issues. But when you think about the 1800s and how, even in the early 1900s, where some of these older houses were built, mine was built in '67, and it's on a lake community, but so there was only one main road going around the lake. But you get these old houses where there was maybe the areas weren't overpopulated like they are today. There's not a big bunch of houses all put together. And as over the years they paved all these streets and put in driveways and paved over them, I remember a study about seeing a documentary one time, and it was saying a lot of the flooding had to do with paving and stuff like that, because the water, as it rains heavy, a lot of the drains get overwhelmed because they're the original drains that were put in, and the water doesn't permeate any soil because it just runs off the blacktop, whether it be the new roads and the driveways and all that. So there's nowhere for this water to go other than look for its, like you said, the water seeps its own level. It looks for the lowest point. It's trying to run down that way, and those are usually the people that pay the most for it. They, at the bottom of the hill or whatever, or a low point in town. So I'll turn it back to you, Neil. KD2TVS.
Well, thanks, Luke. And the electrical thing. You get into a lot of interesting things when you buy a house that wasn't done correctly, or an older house sometimes that somebody had done things to. It's pretty neat and sometimes alarming, some of the stuff you find when you start troubleshooting some of these places. But thanks a lot, and I'm going to throw it over to Jim. Just to give an overview again, and I do want to ask something of Jim, but this was when there was so much discussion after Sandy hitting the island, and the TechNet that I used to participate in sometimes down there, run by K2RIW. May he rest in peace. He's not with us anymore, but he ran that net for decades, and he had theorized that a number of the people who had passed away in Superstorm Sandy had not died of drowning, but from electrocution, because so many of the houses that still had power had been flooded while their electricity was still on. Now, I lived in a basement apartment in Jersey City when we had a freak thunderstorm hit Manhattan and Jersey City. It was pretty much focused right on that center area, which was probably in the 30s in Manhattan, so 30th through 39th Street and the Jersey City Ridge and waterfront. And so much water came down so fast that it overloaded the street drainage systems, and it caused huge backups in the sewer system. Water was coming out of my bathtub like a geyser, and toilet overflowing and everything else. Luckily, so much water got pumped through at once that it really wasn't, let's say, sewage that was coming up in my basement. It was just water, which was incredible. But it got up as high as the outlets, and nothing shorted out, and I'm still with us. It's just an interesting subject, and my own, observations with that is, a number of times I've had water breach an extension cord or something. I know that water itself does not conduct electricity, but tap water usually does. So what's going on here? So over to Jim, K2BHM, for that and other things.
Hey, Castillo, Jim, K2BHM here. Yeah, pure water, technically speaking, doesn't conduct electricity, but when you start putting minerals in it, calcium, magnesium, iron, stuff like that, the free ions do provide a path of conduction. Now, luckily, when you're talking about an outlet, you've got the black wire and the white wire right close to each other, and the path of least resistance is the water in between those two holes in the outlet. It only becomes a problem when it finds a path extraneously through you to ground. Particularly like the olden days when you had an electric drill that was a metal case, and if the drill burned out, one of the wires fried and happened to go and rest against the metal case instead of the other wire where it was supposed to go and complete the path. That made the outside case hot, and if you were standing on a wet something or other, you became the path of least resistance, which is why they came up with putting the green wire down there and grounding the housing of the electric drill, so that if something did happen that the outside became hot, it had a safe, low impedance path to go back to ground, the green wire. And it was a better, easier path to go through that than you. So electricity is an interesting thing, as we all know. I don't know if that answers your question or not, but let me drop and pick up another topic. Talking about density and overloading the sewers and stuff like that and so forth and so on. Very good study on that was done back down in during Hurricane Sandy. My sister-in-law lives in Massapequa, and it's fairly heavily populated down there. So you've got streets and sidewalks which do not allow water to pass through and into the ground. And you've got houses with roofs which don't allow water to go down and into the ground, and little spaces in between the houses where all that water's got to go to. And across from her house, she's only like 2 blocks from the ocean, was a park, several baseball fields, basketball courts, and stuff like that, wide open spaces. And when Hurricane Sandy came, all that area there was open and had a path to get rid of the water to sink down and into the ground. So her house had no water damage whatsoever, and you go a block one way or the other from her, and they all got clobbered. So overpopulation and a lot of blacktop and sidewalks and stuff like that are kind of detrimental in a situation like that when you push the extremes. Anyhow, did I answer the question, Neil? K2BHM.
Yeah, pretty much. I seem to remember it was a heated discussion when Dick was around and ran that net. One of the issues was once he got a theory in his mind and had sold himself on that theory, there was no changing his mind. So that's the way he was. But we had a lot of great discussions on that old tech net, and they're still running it. Somebody took over for him. So and it's I believe it's on the same time as this one. So, another thing that I wanted to mention, and I know you can comment on this, is that a lot of this is simply we're fighting Mother Nature. In cases where we do things without really thinking about the consequences of changing things, without coming up with a way to mitigate it, we're kind of asking for trouble. And one of the examples of that, and I'll let Jim comment on this, is that someone told me once, and I think I did see an example of it, but it's been a long time since I've seen the graphic. Right after Sandy, somebody took a map of the flood patterns in Manhattan and superimposed that on the original shape of Manhattan before they started pushing out some of the communities into the water a little bit and building out off the island. And they were very, very close. So there's an expression about Mother Nature, which isn't polite to say on the radio, but I think we all know what it is. Jim, back to you again.
Yeah, I do remember hearing some comments about some of the areas down in New York City were kind of like a buffer zone between the ocean and the city, and they built on them, and then wondered why they had a problem. Anyhow, yeah, money. When they're looking for land and they want it, no matter what it costs, and no matter what you have to do, and they forget about Mother Nature and so forth, it can be interesting. Anyhow, to get back to the previous thing about electricity, we're all familiar with the GFI outlets and GFI breakers and so forth that trip to save you from getting electrocuted. But does anybody know what's really inside and how they work? Do you want to touch on that, Neil?
Yeah, we could briefly. I don't actually know what's in them, but I know that some of them buzz like a game show buzzer when you transmit near them, even with a QRP rig.
Yes. Basically, there is a tool called a clamp-on ammeter. It's been around for, decades. You pass a wire through this loop, and the loop is a set of laminations that spring open. And you spring it open, put the wire in, let it snap close again, and it becomes an actual transformer. So the magnetic fields from the current through the wire generate a magnetic field in that loop of laminated iron like you'd use for a transformer core, and takes the magnetism into another coil inside, and the meter from there reads out what the current is in the conductor. So you can measure current remotely like that without actual contact. So now, what happens if you put it around both the black and the white wire? Well, the magnetic field from the black wire cancels out the magnetic field from the white wire returning. So the net result is zero. So there could be 20 amps going through the black wire one way and 20 amps going through the white wire back the other way. But your clamp-on ammeter is going to say zero because the two balance each other out. So now, let's say that you have a problem in the electric drill, and the white wire becomes disconnected. And now that case is hot, and you set it down on the ground, and it's now conducting electricity through to the ground. So you have 10 amps going out the black wire, and nothing coming back to white because it's going to the ground instead. It's going someplace where it doesn't belong. Well, now they see a difference. They're not balanced, and they go and trip it and kill the power. And that's basically the whole premise behind the ground fault circuit interrupter. It's sensitive to the point of less than 10 milliamps,
If there's more than a 10 milliamp difference between what goes out the black wire and what comes back to white, it trips and turns the power off. K2VHM.
Interesting. And probably also explains why, they didn't trip when they had the almost fire in Poughkeepsie that time. With an arcing plug that caused so much heat that it melted everything. When the wires finally burned all the way through, the circuit was still active. Back to you, Jim.
Yeah, because everything that was going out one way was going back the other. But that brings up another interesting topic now, too, with microprocessors and stuff like that. There are new breakers that are code now for all bedrooms, but now they've extended it to pretty much everything in the house. And they're called arc fault breakers. The microprocessor recognizes the high frequency characteristics of the arc that was caused when that cord failed. And it will trip on that high frequency component, as well as an imbalance in what goes out the black wire and goes back to white. So that's the latest and greatest. I think it's been about 10 years now that they're code.
And there's new breakers that respond differently than prehistoric equipment as well, correct?
Yeah, well, it's basically three types of breakers. The original ones, which just tripped if the current was too high. And then the next generation was ones that also sensed the difference in current between the black and the white wires and would trip if it wasn't balanced. And now the third type, the arc fault, does all three. Trips if it overcurrents, trips if it doesn't balance, and trips if it senses the signature of an arc.
After witnessing one of these events firsthand, I'm a big fan of that. But it melted everything. And when I think about the fact that that whole wall could have gone up, I mean, God knows how long it was cooking like that. Just scary. And all because, outlet was old, it was worn, plug was heavy. It was an Apple MacBook Pro adapter with the direct plug, not the one with the cord coming out of it. And it just slowly, from house vibration, worked its way out of the outlet until it started arcing. All right. Well, we go off on tangents, but they're good ones. And it's a good explanation for why I'm still with us even after that flood. That was a scary situation. And thank God the way that house had been built, it was another old, row home type of thing. There was an odd, like courtyard type of structure, almost like a shaft between the houses. And there was a door opening up into it from my basement where I lived. And we were able to open that door and a lot of the water flowed in. And in the bottom of that shaft area was a big drain and the water just went in it. The rest of it, my landlady and landlord came down with big squeegees and just kind of moved the water around and then brought me 10 fans and plugged them in and ran those for a couple of days. And I went and stayed elsewhere. But, I think, as I was saying earlier, we really have to start thinking about these things more, is that we're going to have more of these sudden events where just crazy amounts of water come down. And something we just have to be prepared for. Is there anybody else who would like to join us tonight? I think we're going to do a final round, and I'll be happy to end things before 10 tonight because I just had a very tiring weekend, and I think it's just everything this week leading up to it. A lot of you know I've been out for a while, and this was my first week back to work, and I think it just took a lot out of me. A lot of people don't realize that you can get tired using your brain a lot. You don't have to be doing physical things. So, and it certainly was a very taxing brain week. So if we have any last minute check-ins, please come now with your call sign, your name, and your location. All right. Let's crank it back up to the top here. N3EYQ. Oh, sorry. I was trying to speak your language, Paul. Oh, N3EYQ, are you there? Or we may have lost Paul either to a fire call because he's an active volunteer fireman, or he got lulled off to sleep by the sweet sounds of FT8 signals. You still there, Paul? All right. Well, he might have run off in a fire call. We do get some good stories from him about those. So, Matt, KB2GGF, the final comments on everything of the evening.
Well, all the discussion of water and so forth has put me in mind of Florida. I used to work with a woman who had a vacation home, and I guess she was going to retire there in Florida. And one day at work, her neighbor sent her photo. Her next door neighbor sent her a photo in an email attachment of the house next to hers, so 2 houses away from my coworker, where a giant sinkhole had opened in the backyard and the house was sliding into. So, needless to say, she was rather concerned, and just kind of remarkable. As Jim was saying way back at the beginning of the program, that what you don't see, there's a whole bunch of stuff you don't see, and understanding it as much as you can is a very good defense against falling into it, I hope. Anyhow, it's been interesting, so I think this is the last round, so I'll say 73s to everybody, and thanks for the net, and KB2GGF is clear. Back to net.
Well, thanks, Matt. A little trivia question, a little piece of trivia here. Florida is the U.S. state with the most sinkholes. So, no thanks. I guess in order, it's Florida, Texas, Alabama, Missouri, Kentucky, Tennessee, and Pennsylvania. I think some of the Pennsylvania ones might be caused by mining. Not sure, though. But, yeah, I don't think I want to lose my home to a sinkhole. That would really stink. Ooh, that's not fun. So, well, thanks for being here tonight, Matt. Always fun. Lou, KD2, TVS. Probably no sinkholes where you are. There's a lot of rock there.
Yeah, Neil. I live up on a mountain, about 1,200-foot elevation, and all I see is rock in every direction, in my yard and everywhere. But interesting about sinkholes, yeah. I mean, that's something that we don't think about. Like you said, the stuff we don't see. Where New York City, I remember the same thing, and other areas where you get a lot of these sewer pipes or water mains, and they're constantly leaking for a while, and I guess it just erodes the soil about underneath all that stuff, and eventually down it goes. And surprise. But anyway, if you want to get some good, interesting videos, actually on YouTube, I remember last year, because I happened to be in the city that day. It was back, I guess, in July of last year. I'm pretty sure it was. And there was the big rainstorms that flooded all the subways and everything, and all the streets in New York City, especially around that Yankee Stadium area, the Major League in there, the Cross Bronx, and how, with the low-lying areas of the Cross Bronx, where you drive under those overpasses, that all those areas just flooded out, and it's unbelievable. And one thing that maybe Jim knows, but I always was bewildered by that. They show in some of the videos where the subway stations are completely flooded. People are walking in and out of the subway station. The power is apparently on. Maybe to the rails they're not. I don't know. But there's actually power at the subway station, and people walking in and out in knee-high water up on the platforms. And you figure the rails are, are submerged in the water, that nobody ever gets zapped. So I was just wondering about that, how they fail-safe that stuff. So, everybody doesn't gets electrocuted with all that high voltage on that third rail and stuff like that. Back to you, Neil. KD2TVS.
That's a pretty good question. And since we are at the end of the list, I'm going to throw it over to Jim.
Okay, thanks, Neil. K2BHM Jim here. Well, the answer is very simple. You've got the third rail down there, which has a very high voltage on it. And that is one conductor, and the other conductor is the rails themselves. So the train is the path of least resistance between the third rail and the ground, the main rail. So if you're standing up on the platform, the electricity leakage is going to be between the third rail and the main rail. It's not really going to want to jump up 10, 20, 30 feet away to you, because it's got a much nicer path right there, inches away to that iron rail. So that's where everything is going. Now, if by some reason that rail popped up and was sitting there on the platform, and you got between that and one of the steel columns, you got in the way, that's a different story. Just like in a lightning storm, they tell you to put your feet close together and crouch down, because if lightning does hit and it starts traveling through the ground, you can pick up a point at one potential with one foot and a point at a much different potential with the other foot, and then you become part of the conductor. So it's all about path of least resistance and which way it's going. What's the easiest way for it to get from point A to point B? And if you're on point C, which is not in between the two, then you got it made. Anyhow, back to you, Neil, K2BHM.
So wait, Jim, are you trying to tell me that the way that television and Hollywood deal with electricity and water in all of these shows and movies over the years might be wrong or exaggerated? I am horrified.
Yeah, throwing a radio into the bathtub kills somebody? Not necessarily.
There's been a lot of this. But neat. Lou, did that answer your question?
Yeah, Neil. I guess it's a simple answer. And, sometimes we just, like you say, sometimes we make it more than it actually is, and it's simple electricity that seeks the shortest distance between the two, the conductor and the ground element. Okay, thank you. Appreciate the answer. KD2TVS.
Quick question.
Go ahead.
Why is it that all of the birds that are perched on the high voltage lines between the poles don't get fried?
W2NDG for ID. I think I used to know the answer to this because I think we talked about it once before. But I think it's because they don't have enough mass to create a difference in potential. ahead, Lou.
I think it's because they don't have a ground. If they're sitting on the one wire, that wire could be hot. But if their other foot is not anywhere that's going to be, they're going to be grounded. They're not going to get zapped. Back to you, KD2TVS.
I considered that. I think the last time that this had came up in a different conversation, but I believe if one of us touches that line, it doesn't go as well, right, Jim?
Well, if we were sitting on a line like the bird does, no problem. But if we start to get too close to one of the other lines, let's say the squirrel is scampering around and he jumps from one line to the other line. So at one point in time, his nose is an inch or two away from one line, and the tip of his tail is an inch or two away from the other line, and the line has got 13 tube on it. You have a loud percussive disassembly of a squirrel, and ashes floating to the ground.
All right. And I know that the interesting thing that a lot of us have seen maybe the video of was the guys that do the maintenance on the high tension wires wearing those special Faraday cage suits, and they have to charge the suit up to the potential of the line before they go on it.
Yeah, as long as all of your body is at the same potential as the line, then you're perfectly safe. It's when you become in between lines of different potentials that you have to be careful.
All right, makes sense. Oh, high voltage, another topic one night. What do you think, Jim?
Yeah. When I was working on the X-ray systems, the X-ray power supplies were capable of putting out 120,000 volts at half an amp. So they were pretty respectable. You didn't have a second chance. You never made a mistake with them.
I know those things well, as you know. All right. Well, I think we are through everything here, and I'm going to take a little break before I head off to bed tonight. So we did have a couple comments here that came up after we started getting into it. KB2RWW, Bob checked in here and said, there's nothing funnier than an all-plastic Craftsman drill with a ground. Yeah. So what's the point? And yeah, my brother says, electric fan into a tub and Dr. No, Friday guy. Yeah, that's what I was referring to. Stuff like that. Maybe not, maybe so, not a guaranteed fry. Mr. Lots of Zeros 9A. I'm not sure who that is. Someone else just checked in, but I'm not sure who that is. Just got back from stacking wood. Oh, wow. We're in the majority here tonight. There are 3 Goldsteins on the net. Evening, Alec. All right. So that's my son, KD2YFU, checking in. But I think we're going to close things up. If you just are coming to the video portion of the net or even the audio portion, you can rewatch it by going to the YouTube channel at W2NDG, Science and Technology. Once we're done recording, all of the nets are archived on the channel. So let me drop final comments from Jim, KD2BHM.
No, nothing really much. I'm just as happy it was a little short tonight. I can associate with you with all my back issues and so forth. It's very difficult to get a good night's sleep, and I'm about ready to pack it in myself. So anyhow, enjoyed the net tonight. Thanks, guys. And I'll pass it back over to you, Neil, to button it up. K2BHM.
All right, that's fine. And thank you, Jim. Thanks for all the help here. You are definitely a good authority on engineering subjects, and I may have to pick your brain myself, but I'll give you a break. All right, let me drop. You have been listening to and or watching the Overlook Mountain Amateur Radio Club's Sunday Night Science and Technology Net. And thank you for joining us. We meet here every Sunday night at 8 p.m. and we invite you to join us. You do not need to be a member of this club to participate, but we would love you to come check us out. And you can check us out at omarcclub.org, omarcclub.org. And if you like what you see, there's a form there you can fill out and apply to become a member. A lot of things go on here, too. So we'd love you to be a member and participate. And there's a bunch of nets. Let me cover those real quick. There are nets daily at 8:35 a.m. and 6:30 p.m. The 8:35 net is a roundtable net hosted by a rotating cast of OMARC characters, just having people check in, tell us what you're doing, how you're doing. That net started at the beginning of the pandemic just to keep everybody social and make sure we were all okay. Also, the 6:30 check-in net, very similar net for similar reasons. Want to know what you did during the day? Do you have any questions? Did you have any problems? Do you need any assistance? That is a directed net, also hosted by a cast of OMARC rotating characters. So that sounded kind of odd, but you get the idea. On Monday nights at 8 p.m., all of our other nets are at 8 p.m. Monday nights, it's the UNDR, UNDR, or the Ulster and Northern Duchess Readiness Net. That's a net where we talk about emergency services and being prepared for emergencies, and what to do in the event of an emergency, and how radio fits in with all of those topics. Please join us 8 p.m. on Mondays. Thursdays at 8 p.m., Dave, K2GLV, hosts the Thursday Night Technical Net, a more ham radio-oriented tech net, but sometimes dealing with the subjects of computing and sometimes computing in ham radio. Dave takes check-ins and looks for a topic, maybe somebody who's looking to troubleshoot something or just has questions. If a topic doesn't develop, Dave throws one at us, and he's very good at coming up with topics. That net can run sometimes 4 or 5 rounds or more into the night. Join us on Thursdays at 8. This net, of course, Sunday nights at 8 p.m., is the Overlook Mountain Science and Technology Net, hosted by myself, W2NDG, and Jim, K2BHM. We thank you all for coming. We now return the repeater to its regular use. And everybody have a good night. I am ending the YouTube stream now. 7-3 all.